Okay, hello. Welcome to part 2 of 30S Applied Math, March 24th. I did record this lesson earlier. I tried, and I know there was one, but the audio apparently stopped working halfway through the video, so I'm re-recording the lesson. We started with a review of homework. So the homework was assignment 8, law of cosines assignment. So it was just, there were 7 questions, finding the missing side or the missing angle, and they were law of cosines questions. Now remember those questions that can't be done through law of sines. Law of sines is very straightforward, very easy to use. Law of cosines is a little more challenging because there's 2 different versions of it. It's the same law, but there are 2 different versions depending on if you want to solve for a side or an angle. Whereas law of sines we can use to solve for a side or an angle, but the format of the formula stays the same. Confusing, I think, for students. Now, I mentioned yesterday the law of cosines is used when we're given either information for side angles, side triangles, or side, side, side. So when you're given a triangle and you're just given all 3 sides, it's a law of cosines question if you're given no angles, or if you're given 2 sides and the angle between those 2 sides. So it looks like the angle is being chomped, swallowed up by the 2 sides. It's a law of cosines. It can't be law of sines because for law of sines, you have to have a complete partnership. So here, if I look at this first triangle, it's going to be a side angle side, right? It's the angle between the sides. So it's a law of cosines. This one again, law of cosines, right? Side angle side, the angles between the 2 sides. This triangle was law of cosines because you were just given side, side, side information, as well as number 4 was side, side, side. That was a little challenging. That's a question I did done earlier when I tried to record the first time. So you weren't given this info, but you were given these 2 ticks. And remember when we were doing a little bit of measurement earlier? If I'm given 2 ticks, that's my automatic code that means that the 2 sides are equal. So as long as I'm given the length of this side, I know that the length of the side with the same notch is also 74 feet. And then the angle between them is 30 degrees. So you can see I have another side angle side question. And that was enough to be able to enable me to solve for the missing side. So the missing side is equal to the 2 sides. We square them and we add them up. Subtract 2 times the length of the 2 sides again, multiplied, times the length or the cosine of the angle. Find that whole answer and I square root the answer. I get 38.31 feet. And that is the side, that's the sine of x, right? 38.31 feet. The last 2 triangles in this assignment were side, 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 and side, side, side. So they were law of cosine solving for an angle measure, right? And maybe I'll do one of those quickly here too. So if I'm told to solve for an angle, and this is the angle I'm solving for, this is its partner side. This is in the formula, this would be angle A and this would be side A. So this is the side I have to subtract. So in order to find cos of the angle that I'm missing, I take these 2 sides and I add them up and I square them and add them up and I subtract out the side that is partnered with the angle. That's very important that you know which side partners with the angle because that's the one that's subtracted out. Then I divide by 2 times 10 times 15. Okay, so in your calculator, and I recommended today that you can just use, it might be easier just to use your little scientific calculator for trig and forget about the graphing calculators because they're a little easier to use. So if I do in my calculator, I put my bracket in and I go 10 squared plus 15 squared minus 12 squared, close my bracket, divide out the bottom, bracket 2 times 10 times 15, close my bracket, whoops, 10 squared plus 15 squared minus 12 squared divided by 2 times 10 times, whoops, could be what I did wrong, times 15 close bracket, and I get 0.603. Now what I have to do, that's actually just solving for cos of the theta, right? 0.603333 repeating, but I don't want cos of the theta, I just want theta. So my very last step, I have to cancel cos, so cancel cos, and then I should just be able to hit the equal sign, and I get 52.89 degrees. Where the back of your book probably says 53 degrees. So that's how I use the law of cosines to solve for a missing angle. I did show yesterday that it's really at the end of the video, for anyone who's interested, it's just this, it's the same formula, but it's isolated for different things. And then I assigned for homework, assignment 9. And I said that I would do a couple of questions in class. So I'll do, I decided to do 3 and 5. Because they sort of, number 3, I will give you some extra practice assignments. I'll post them on the blog, hopefully tomorrow. I just have to find some good review assignments for you to do, and then maybe I'll get you to submit a review assignment with answers for me. But I'll post that on tomorrow's blog. So number 3, we have 2 boats leaving a dock and the angle between their paths is 63 degrees. So that means if they're leaving a dock, in a math or science diagram, that would represent just a point. And I've got boat 1 travels in one direction, boat 2 travels in the other direction. And it says the angle between their paths is 63 degrees. So that gives us this angle between them is 63. An hour later, one boat has traveled 3.8 kilometers. And the other boat has traveled 5.2 kilometers. How far apart are the boats at this time? Well, you can see where the triangle forms, right? This is not a right angle triangle, I know, because this is 63 degrees, not 90. So they're asking me for this. So you can see that it's a law of cosines question, that same question that we were just looking at a couple of minutes ago. It's a side angle side, so if I want to solve for x, I know I have to square root the whole answer. And I just take the sides, I square them, and I add them up. And then it's -2 times the sides themselves. No squaring here, just the sides themselves, times cos of 63, and that's it. Basically, the law of cosine solving for a side is just really is just testing if you can substitute the values into the right place. So if I do all of that in my calculator, and I'm going to get, oops. And I get 4.85 kilometers. I punch all that into my calculator. So the 2 boats would be 4.85 kilometers, I guess an hour after they departed. Okay. Again, when we're working through this stuff, if you have any questions later on after you want to try them at home, please just email me or come through live chat if you can. I know some of you can't watch the videos live, so that's fine. But whenever you can just email me. And my email info is on the blog, and it's also I included in the pinned post at the beginning of the blog. Okay, so let's take a look at number 5 as well. Number 5 says, it's a little trickier, I think. This is a very tricky one, which is what I wanted to go over it with you. And I'll have some more review questions for you to do as well on your own at a later date. So let's just try this one. An observer is standing 100 feet away from a building. And as I mentioned in class, it's always assumed that buildings are built at a 90-degree angle to the ground. An observer is standing 100 feet away from a building. So here's the observer standing and looking up at the building. The angle of elevation from the observer to the top of the building is 41 degrees. Okay, so we talked about angle of elevation in class. So it's from the ground up. So this is 41 degrees. Then it says there's a poster on the side of the building. So if there's a poster on the side of the building, it's some kind of poster like this, right? Poster. The angle of elevation from the observer to the poster, and I'm assuming they mean to the top of the poster, is only 21 degrees. And that makes sense. Because the poster is definitely not as high as the top of the building. How far is the poster from the top of the building? So we're looking for this distance. All right, so I'm just going to let you look at that for a sec. It's a tricky question, but this is actually a right angle triangle question. You can see because it involved a building, and buildings are built at 90-degree angles. So therefore, I see two right angle triangles here. And if you kind of look at it just clinically, analytically, you'll see that they want me to find this. They want me to find the difference between the height of the building and the height of the poster. Really, that's what they want me to find. So if I could just figure out what this side is and this side is, I'll be able to figure out what X is. So let's see what we have. I see a large triangle, a large right angle triangle, and a small right angle triangle. So if I see the large right angle triangle, I see this, right? They both share this 100 feet. But this angle has 41 degrees. And for the small triangle, it also has a side length of 100 degrees, but 21 degrees. So if I find the length of this side and then the length of this side, the difference between these two should be my difference of X, right? I'm going to call this height. Maybe I'll call this capital H for height. And I'm going to call this lowercase h. So if I find the difference between capital H and lowercase h, that should be X that I'm looking for, right? So let's see. I'm going to give you a sec to look at that. It's right angle triangle, so we can never forget our right angle trig. And our right angle trig is the ones that involve sine, cos, and tan. So remember the angle's the boss. This would be the opposite side, right? And this would be the adjacent. So that leaves me to tan. So that means tan of 41 degrees equals capital H over 100. The unknown's on the top, so I multiply. Capital H will equal 100 times tan 41. And that's going to give me 86.93 feet high. And this one, it's the same setup, right? It's going to be op over adjacent, except it's going to be much smaller height. So again, it's got to be tan. So tan of 21 equals little h over 100. Little h equals 100 times tan 21 degrees. Little h equals 38.39 feet. Okay, so the difference between these two, big H minus little h, 86.93 subtract 38.39. Is 48.54 feet. So the question asked, how far is the poster from the top of the building? The poster is 48.54 feet from the top of the building. I think that was a very challenging question. So try the rest of the word problems. I had said earlier in the earlier video that didn't quite upload properly that I'll give you some review stuff on just differentiating between law of signs and to use which, because we haven't really had a lot of questions that review that. Word problems, and then we'll have maybe I'll post a hand-in assignment to hand it on the blog. I also posted on the blog, if you read the first post, there's a new page titled Booklets, and all the PDFs of the booklets are there. If you didn't come into class during the last week and didn't get all the booklets, you can find them there on the blog. So I'm going to end now, and I will see you tomorrow.